because you know I've gotten 92 slides. Hi, everyone. Thanks for coming. I know it's the end of the day. Can you all hear me? Yes? Woo! All right. So today we're going to talk, or this afternoon, or almost this evening, we're going to go ahead and talk about how to parse mobile apps that are unsupported by commercial forensics tools. So I work in digital forensics incident response, have for a while, and what that means is after an incident or after a crime, I'm going ahead and parsing data and looking at it. And now actually, I work for a company that builds tools to do this. I'm not talking about any of that. And I'm talking actually about what to do when they don't. So I guess it's the antithesis of what my company would want me to talk about, but that's cool. They're not paying for me to be here. And then the second thing I do is I teach mobile device forensics at George Mason University. I've ran 2 mobile forensics labs in US government as a contractor, and I've also worked as a consultant. So I've done both sides of the house in terms of commercial and government law enforcement, IC investigations. How many people in here do forensics? All right, got like 4 or 5 of you. And the rest of you, InfoSec? Okay, hackers? Just straight up hackers? That should be all of you. You're all hackers. And students. Okay, good mix. Very cool. Okay, kind of tells me where to go. So I have a couple of goals for this session. Number 1 is to show you that your commercial tools will never get you all of the data and to inspire you to dig deeper, do the manual work, and find data. The second thing is to give you a methodology as to how to do it. So I'm going to show you how you can do it, and you can do it, okay? The third one is to understand how to parse and the importance of validating data, even if your commercial tools do it. I'll share some stories with you. And then overall, to give you a methodology to parse apps you've never seen before. So why do we care if we have tools? Well, if you look just at the Google Play Store and the Apple App Store, you can see there's over 4 million apps. If you take every commercial tool that does mobile forensics combined, they're going to parse about 400 apps. So chances are your nefarious actor might be doing something different. So in this, we're actually going to go through, built a scenario here to show you this, and I made some guidelines, so I just want you to know the left and rights. I wanted to do Android just for the simple reason, and I want to take something really basic, because I do have the understanding that unless you have a jailbroken phone, unless you're law enforcement, you're not going to get a full file system image. And if we're digging for additional data, you're going to need a full file system image. I also want to use entirely open source methodology for this demonstration. So everything you see here, you can do on your own. I also want to show something that doesn't store in SQLite, because that would just be cheating. Okay, and then stress the importance of scripting. So the entire goal here is the methodology. And so this methodology is discover, test, find, parse, script. You will hear that from me over and over again because it's really simple. So starting with discovery. How do you discover if there's an application on your phone that you missed when you ran a commercial tool, a Celebrite, an Axiom, an XRY, whatever tool? Well, first, you want a physical image or a file system, but let's say physical or a file system image. If you have a logical image, which is much like a backup, that's not going to help you because all of the data that's there's already been interpreted by the operating system and read. You do want to look at what the tools that you do have at your disposal ran and found, because you don't necessarily want to duplicate work. You want to look at what's installed on the device and what's been used, as well as look at permissions. And we'll talk a bit about what kinds of things you're going to look at in permissions and then validating in the App Store. So first, creating that physical image. For those of you who may not be familiar with doing this, I'm going to walk you through how to do this in an open source methodology. So use whatever your organizations will allow. In this instance, we're going to use a twerp recovery. Recovery modes by default have root. When you have root on an Android phone, you can get a physical image. That's the basics of everything. So for this case, we just used the DD command, which is the most simple command. I did one partition, and that's neither here nor there. So I was using an Asus Nexus 7. The reason I was using this is I have 2 of these. I have 2 of these because I have 2 children, and they are my little data creation monkeys. I'm not joking. They download every app I approve for them to test, and they communicate on them. And did my husband make it into my lecture? No. My husband was playing the CTF. So this is what happens when a forensicator marries a red teamer. All right, so who married when they met in the Marine Corps, and neither was yet a forensicator nor a pen tester. But all you need to do is Google the Team Win Recovery Project and go ahead and find a twerp image for your device. Note, twerp is a hacker collective. I stand not by anything they may have, so please test on an exemplar. So installing ADB. ADB is part of Android Studio. So just go to Android Studio, click the download button, and download the command line tools for your operating system. Pretty simple. This is a command you're going to use to connect to your device. You're going to do /ADB devices. Then you're just going to do ADB reboot bootloader in order to go ahead and put your device into the bootloader mode so you can flash a twerp image. Then you're going to go ahead and flash the recovery twerp image. If you want to copy these slides, you can get them because I know I'm sending command line at you fast and furious. I did give you 92 slides today. I don't expect you to take a picture of every one. So once you do that, you're going to go ahead and go give yourself an ADB shell so that you can see all the partitions on your device. Anybody want to guess how you can identify the user data partition? It's the biggest one. Very good. So your MMC block 0 or your mounted 0, there's some emulation that happens with Android 8 and 9. We're not going to get into that. That will be the full device, but we'll include all the partitions you might not have interest in. In this instance, it's block 0p30 is the one of interest. And if we actually run the by name command, we can actually get the names of each of those partitions and not the size. You can match those up, and you now see that's user data. Woohoo! We're going for user data. All right. So what you need to do to user data is you need 2 command prompts open. 2 command prompts. This is really important. You need one where you're going to go ahead and get your shell, right? You're going to forward your traffic on your port. And then you're going to go ahead and say, give me that partition, use BusyBox to netcat it to that port. Then you need your second window to go ahead and direct your netcat to go ahead and write your image. Sound good? Sometimes people get confused by that 2-window thing. All right, so once you've done that, go ahead and take your image and run it through your commercial tools. This is the only time I will show the commercial tool my company makes because I am showing it failing. Hashtag worst vendor rep ever. The point is it is finding no chats in this data set, and trust me, I built this data set. It's full of chats. Now, what you will find on here is lots of games. This is packages.list. Don't worry, I give you bigger screen caps. It'll make more sense when you take it home. So on here's lots of games. I'll tell you a funny story about Clash of Clans. I was trying to get chat data in Clash of Clans. You have to get a level 4 town hall. How many of you have played Clash of Clans? I am so not a gamer. So I'm sitting there with my kid, and I'm strategically trying to get the level 4 town hall. He's just telling me, Mom, you're playing wrong. And I'm like, no, my objective is different. That's okay, he learned about objectives. So, so I get my packages.list, and I'm kind of getting the scope that this device has a whole bunch of different games. By the way, if you care, we're not going to look at Clash of Clans. Clash of Clans stores all the data, guess where? On the cloud, not the device, and this is a device forensics class, not a lecture. This is not a cloud one, so we're not going to get into that. But at some point, if you want to hear that, I'm happy to talk about it. It's not that you can't find the data, it's just a different way. All right, so here's your packages.list. It lists every single application on the device. That's one way to find out what's stored on your device. Still doesn't tell me what's been used, still doesn't tell me what can chat. So what are some other ways? com.vending.android will list every single purchased app. And you'll see here that Scuba Lover has purchased com.twitter.android, and we see an epoch time, January 1, 1970, for the timestamp. But it freaking lies. Don't trust com.vending. And the reason is because if you have multiple users on the same device, which you can do on Android, it will attribute applications from one user to another that they never owned. So for those of you who do forensics investigations, don't rely on the second thing. I went ahead and took a second device, installed the same account, threw the device into airplane mode before it could download the applications, and it said I had them installed and paid for. So it can lie 2 different ways. Don't trust it. It's actually very important. I hope you also get out of this that Your databases will lie to you. You need to know what data means. Please test. So here's some really cool stuff. And this is cool because none of the commercial tools do this. And these next couple of slides, and this was stuff that I released in the summer. And I'm super excited about this stuff. So there is actually Android usage stat. If you have a physical, you can... Oh, shoot. Guys, I run around. He knows that. I'm so sorry. So Android usage stats. It tells you exactly which files in the background, the foreground. It gives you a couple of different folders. And then there's Android usage history.xml, which tells you the same. And it gives you this lovely XML. And what's so cool about this XML is you get the last time active. You get the package name. Package names, by the way, are, looks like a domain name in reverse. It's usually company dot platform. If you're wondering how you can get those, if you ever go to the Play Store and look for an app, it's what's in the URL bar. I do this all the time to go back and forth between the phone I'm looking at and what the name of the app is, if I'm starting that way. And if I'm looking for a particular app, I look in the Play Store for the app and then pull the name of the package name from there to move forward. So there's also battery status. And battery status is really cool because it's almost like the System Resource Usage Monitor, or SRUM, that exists in Windows, but it lives on Android. And the reason this is cool is because it gives you a whole bunch more information. So batterystats.xml tells you exactly how much charging is happening, but that brings you to the battery stats dump. And the battery stats dump actually tells you a process with a UID. Now, there's obviously a reason I'm telling you about this UID. It's because it rocks. So the UID for Twitter is 10103. Can anyone in here remember that? No, you're full of it. No, it's OK. I promise I'll show you the same thing. So, all right, you know, at this side of the room, you've got to remember 10103, because there's two things we've got to correlate here. So then there's recent images. Recent images is really cool because it saves the icon of the applications you've last looked at. And it starts the file name with a number. This number is the task ID. So we've got a UID and a task ID. So task ID 244 is for Twitter. Now, and what's your number on this side? Oh, you guys are awesome. Great. Where are you guys when I'm doing exams? I have to use a notepad. All right. So if we look at 244, we've got our file information. We've got a date and time. And what that is saved for is, you guys know, when you change your apps and you go down, you hit that button on the button. Well, I guess, wait, sorry. How many people in here use Android? How many people in here use iOS? That's how I know a hacker with more Android than iOS. Hoorah. All right. How many of you rock both? All right. Oh, yes, those are my people. All right. How many of you are rocking a BlackBerry? Good. No shame in this room. Oh. All right. No Windows phones in here, right? Because you got a good camera on it, right? Ooh, let's talk after work. I'm calling this work now. All right, so moving on. So we look in a recent tasks folder, and guess what we're going to see there? We're going to see that recent task ID with an XML. When we go ahead and look at that XML, it ties the task ID to the UID. 10103 people, you just got coordinated to 244. And that's cool because now we get the first active time in epoch timestamps and the last epoch time, as well as the last time the app was moved. So now we've got the task ID for Twitter, the UID for Twitter, and the first time it was moved. Now, Jessica, why are you telling me all this? Because we have to figure out what apps have been used on the phone to figure what apps might have been used to communicate, and now we have a way to do it. We didn't used to have that. But there's more. So if we actually go to Shortcut Services Snapshots, we actually can find those pictures by task IDs that were saved so that you get that gallery when you hit the button. Now, what's really cool about this is you would never, ever, ever find somebody who you're just looking at on Twitter just by pressing this button. You would normally, you and your Twitter caches can get things you've, DMs, and you can get history of posts, but you can't just get pages you happen to look at. But this was the last page they were on before they switched apps. So how do you really know? My buddy Alexis Brignoni wrote a script for this about a week ago called USRT. It made me so happy. It's really cool because it even brings in that image to it. But the whole goal here is now you can figure out what applications were actually being used, not just installed. Likewise, if you guys know Sarah Edwards, she is an RIT alum, and she does a lot of really awesome iOS work, and she wrote an app to do the same kind of stuff for a similar type of set of databases called Knowledge CDB in iOS, so that is that place. All right, so now you know what apps are used. So now you're going to take that information and go to packages XML, which is going to give you the permissions. And why do you want permissions? Because now you've got to figure out what of those apps might have been used to communicate. Remember, we're looking for chats. Once you've identified the ones that have the types of permissions you're looking for, which might be things like read contacts, get SMS, etc., then, and only then, you're going to check out on the Play Store and see what functions it has. And sometimes you won't get all the functions listed in the app. This is a game, Word Chums, and the only place that I can find is a picture of the functionality with a chat bubble. So in our image, we wound up having 3 games, excluding Clash of Clans, which only stores in the cloud, that are possible to have chatting in. And they are Chess with Friends, Word Chums, and Quiz Up. So now that we know that, we're going to go ahead and see if we can find some parsers in the World Wide Web, even though I did run these through 6 different commercial tools, none of which picked up these chats. Now, luckily for me, cheeky forensics monkey, best person to follow, he's really cool. He actually does a lot of Windows Phone forensics, and Forrest left, darn it. He had a parser for Words with Friends, and it actually worked on Chess with Friends because they use the same schema, both by Zynga. So went ahead, looked it up, pulled out that SQLite database, went ahead and parsed it, and we see this amazing message between Elvis Presley, Elvis P74, and Frankie Blue Eyes 2016, where they're talking about chess. It's very exciting, not my nefarious activity, time for me to move on. So now we need to figure out how to get data out of Word Chums and Quiz Up. Our discovery phase is over. So now we got to test. So our next objective in testing, now that we've discovered our apps of interest, is to go ahead and create test data. Now, the reasons you're going to create test data are a multitude. Number 1, test what you think is happening. Number 2, validate your parsing and support. Number 3, ensure you understand data storage. The number 1 way to understand the data storage is to start with things you know. If you have known data, it's going to help you decode later. Also, this allows you to validate your parsings. Don't assume. When you assume, okay, so Quiz Up. We're going to talk about Quiz Up, right? And you see Quiz Up right there. Quiz Up made an entire database of all of these avatars and added all these people to my contacts, okay? I was creating the test data. This wasn't data off evidence, right? When you start Quiz Up, it starts spinning a world and shows an avatar of 10 potential connections it's going to connect you to play the game, okay? And then it matches you with one person, you play them. In my contacts was not just the people I played. It was everyone I could have potentially played. And it wrote it to my Android contact database on my device and had the avatars in there. So just because you see data and you can parse data and it makes sense up here, doesn't mean it's factual. You've got to test. So I've already given you 2 examples of BS data being placed in phones that potentially you could make an assumption that it means something. Don't let the other side have that reason if you're going to court, please. So in this, I mentioned I was using these Nexus 7 tablets. The first thing I do is I build profiles, and I save these profiles. I actually keep them in a KeyPass database. I just had them here. I have lots of profiles. Lots of my profiles talk to each other. I actually have made a community. We have an actual Slack of a whole bunch of people who in forensics create and maintain test data profiles, so all our profiles can only talk to each other safely without ever bringing in IRL data. And this is critical. So if any of you ever are in that position, we will vet you first. We will go over game ground rules with you first, but we'd welcome your profiles to talk to our profiles. Don't worry, this password has long been changed. Don't think that you just pwned Frankie Blue Eyes. All right, so one other thing. Ensure that the version of your app that you're testing on is the same as your device. If you want to know how I do this, when I get my full physical image of my evidence, I actually steal the APK out of that physical image and load that onto my test device. No better way to make sure you're on the same malicious version as the person you're investigating. I'm joking. Hopefully it's not a malicious version of the app. So I also screen cap everything as I go. And so this was a screen cap of me saying, now you want to make things move in the character of Frankie Sim to my buddy who was playing the king. The question was, am I using ADB Live to capture the screenshot? Since I'm using test devices, no, I'm not, because sometimes I'm creating geolocation data as well. So I'm usually just screenshotting because I know that screenshots are going to go into my DCIM folder. And since it's my test device, I actually have my screenshots in my same forensic image where I'm doing all of my other validation and parsing. So now we've got to find the data. You've got to find where that app developer chose to put all of their databases, right? Now remember, data can be stored in multiple places. And just because you find data in one database area doesn't mean you will find it in another. Oh, and by the way, when you're testing, you're going to have to test with different storage areas if your app settings allow it, because you don't know how your user had their settings, right? And you don't know what those settings look like in the databases because you haven't set them up yet, because they'll just be flags also. So it's important to make sure you're denoting and writing down every single step you take. When I do my testing, I actually wait a minute between each function. I do the same thing when I build mobile CTFs. So data can be stored in multiple places, and just because you find some of the data in data/data does not, and followed by the package name, does not mean that you're not going to find data in media/0. These just happen to be two of the most common places. Look at all the possible files in each path. Pull any associated key files. I definitely keyword search things I expect to see, like sender, receive, chat, etc. I go ahead and grep. And then I use the appropriate viewers if I can. I'm actually going to go back to your question for 1 second. You absolutely can live test across ADB. You also can do this on jailbroken iOS devices. And on jailbroken iOS devices, Sarah Edwards at macforensics.com wrote an amazing post about how to do it on iOS. You also, for Android, by the way, can do all of this in emulation. You can't do that for iOS. And there is a great virtualization post out there if you want that. That's Alexis Brignoni's. I'm happy to share that with you. You can do that with Andy. Again, all of this is complete open source free methodology that you can do. So you don't need physical devices to test. Just make sure that your emulations are the same operating system version, or otherwise you're going to be completely out of luck. And again, just sideload your APK. Sideloading APKs is like my favorite hobby. You guys have better hobbies? All right. So we start looking at QuizUp. And when we start looking at QuizUp, we can actually find this data. There's actually a cache chat history and a cache conversations that I find in Media0. So I'm going to go ahead and start looking at that. And yep, I've definitely got data there. I think I give you, no, I don't give you this. I'm going to show you this data really close up in a little bit. Then looking for word chums, data's in a completely different place. It's in Datacom. And this is what I keep talking about, guys, with the package name that comes up. Datacom, then the package name. And then I have the multiple chat databases and multiple friend databases. All right, now it's time to parse, now that we found our data. Discover, test, find, parse. Script, but we're on parse. All right, so you got to break down the data. Next step is to turn it into human readable format, right? And we don't know what we're going to see. So you may have to correlate tables and databases. You're going to have to decode data, and you need to think about the basic fields. So you expect to have a sender and receiver, but sometimes you'll just have one, and the opposite one will be your local host, okay? So it can be sender or receiver or two separate columns or fields. It may not even be columns or fields. This might just be a string of XML or JSON, but they may be one. And if they're one, your direction is going to determine if it's a sender or a receiver. You may have time and date. They may be one field. They may be split. Direction, you may have direction, sent or received, but that may instead be determined by status. Sent, read, unread. Status itself might infer the direction. So in a really slim database, you could have a party, either sender or receiver, time, date, one field, and just the status, and that's it. then hopefully you want to find attachments. Note attachments oftentimes can be in a completely secondary data storage, and sometimes this is one of those things you can do by settings where you're going to actually find attachments in the SD card emulation. And remember, you may have SD card folders even if you don't have an SD card slot, because an onboard eMMC in real life is just an SD card. Literally, you can pop the chip off, put it into an SD card reader, suck it into an SD card converter, and put it through a write blocker. Like, I've done that many a time. They're really just onboard SD cards. You're going to want to find the messages and any geodata. It's just the things I'm looking for. Now, I've got like this sometimes list. Sometimes it's SQLite, which you kind of pray for because it's so easy. Sometimes it's open source, but sometimes it's going to be a .dat with proprietary formatting, which is what we've got here. Sometimes it's all plain text. Sometimes it's encoded. Sometimes just the chat data is encoded and the metadata isn't. Sometimes it's the reverse. And sometimes there's just standard encoding that we're going to find. So looking at QuizUp, that is a freaking just a bunch of words, right? But it's really easy to decode. So can you guys see that? It's literally a bunch of words. It's not that bad. I can actually just hit return and make that human readable. Now that's human readable. I can see when it was created, who the from player is. Yes, it's an ID, but I can convert that later. I can see a message ID. I can see read equals false. I can see text. This is all clear text. All I needed to do was open it in Notepad and hit return. Now, to be honest, am I going to do this manually? No. What are the reasons I won't do it manually? Because one, I'm probably going to see it again if it's a nefarious actor. And two, I've worked cases where there was this really, really easy app. I could have done it all manually, but there were 7,000 entries. Was I going to do that for 7,000? No, I scripted it, right? So here, this was fantastic because I was playing my friend, Caesar, and he was the other character, and we were playing, and the category that we were playing here was Disney princesses, and it's the only category where he kicked my ass. So I definitely made fun of him for that, but in character, and told him it was because Lisa Marie was his little princess. Get it? The king, princess, never mind. Maybe way over all your heads. Maybe I'm old. All right. Now looking at word chums, this one is not as easy to read. I don't see human readable text. I see a .dat file that's proprietary. But you still can deal with this. How do you deal with this? You pull it up and you look at your screenshots, right? You know what you need to find. So in my screenshots, I have time date stamps, I have who sent the message, and I have the calls. So I can see that first message of, now you want to make things move. I can see this. Oh, shoot. That message isn't in that screenshot. That message is in a different conversation. I had two conversations because it's very plausible in a chat message to have conversation IDs. And the only way I can check that's a conversation ID is if I make sure that those conversations are happening out of order. So I don't want to have conversation 1 between 2 people and then start conversation 2. I want to have them intertwined so I can see those differences in my data. Now I can start parsing. So I'm starting with this Unix timestamp. And the first one I see is the Unix timestamp for the last message received, followed by the number of messages within the database. This is really cool because the beginning tells me where I end. And from writing a parser perspective, thank you. Thank you, silly app. And now I do see that my husband was in the room, so I apologize for saying you weren't here before. He was hidden behind other people. All right, here's a game chat ID. Now I know where the game chat is. I've got a user ID. And again, I know this because I was looking at the 2 different sets of data and comparing it to my picture, followed by a Unix timestamp, followed by the message. I now have a pattern. So now I can write a script. So again, why are you going to write a script? In case you ever see the app again, you don't want to do the work again. And if you have a script that you can just run in your automated framework, be it that you're running something like Plazo or in whatever tools you're using, that's great. The second is if it's too much to parse by hand. And since word chums in this instance was the one with nefarious activity, that's the one we went ahead and wrote a parser for. Oop, I had a video. Aw, there it goes. Okay, so we've got our 2 databases of interest, the chat and the game database, and we've got our Python script. Is it not really playing? Was like it teasing me? There it goes. And so now that we know what we've got in our folder, just going to go ahead and open up Python. So opening that word Chums parser script, Python 3 wordfo. So wordfo.py is the script. We get a message that just gives us that last date stamp and total number of messages, and then we'll have an output in a CSV, and now we can see all the lovely content, and you can see that basically the scenario here is that Elvis Presley is very upset that his famous rhinestone suit that he wore at Madison Square Garden has been stolen and is on display at the Hard Rock in Vegas. So he confers with Frank Sinatra to go ahead and have Frankie and his Brat Pack go ahead and steal back his suit, and they're going to meet at New York, New York. You don't get the puns, I'm sorry, I really am an old lady. I put a lot of time into my data gen scenarios. I will tell you the funny story is that if you actually go through this whole case, I have a whole scenario of do lab with this, and you know, people can go ahead and find that they've screen capped the route and set times and everything else, but everything cannot be parsed by commercial tools. At the end of the day, that's the whole point. I will tell you that this is the suit that was stolen in this scenario, and I actually, while at Hacker Summer Camp, of course, decided that I was going to go to the Hard Rock and take pictures of it because it really was on display there and edit them into my data set. You know that it actually happened to be on loan with the exception of the belt. The belt was on display. The suit was on loan to an exhibit in Alaska when I happened to go there. But get this, in that display case was a Brat Pack display. So I worked into my scenario that Frankie then switched suits so that he could walk over in the other suit to get it there. I was so happy. So anyway, the whole point is, A, try to get a physical image if possible, because only in a physical and file system image will you be able to find the types of data that's not going to be parsed, because there's over 4 million apps just between Google Play and iTunes. And there's only support for around 400 apps by commercial tools. 2, to look for other sources of data so that you can get more information, and then that there is a methodology that you can do, discover, test, find, parse, script, and that will get you through your analysis. So how do you keep up with mobile forensics? Here is a bunch of really cool mobile forensicators who are on Twitter who are regularly tweeting out about really cool things. Questions? That was 92 slides. No, I realized that was really quick because I just ended a half hour early on 92 slides. So I'm apparently crazy. So, questions? Yes?
How hard is it to really present this data for random apps no one may have heard about unless they close?
The question is, how hard is it to present data for random apps that no one may have heard of in court? That is a great question. So, when preparing data for a forensic report, you need to show what the information is, and if you can show it in a way that's the most understandable, that makes the most sense. So if I'm showing chat conversations, I'm going to show it in a chat bubble format because that's what makes sense to lay people. How do I prove? Well, in my forensic report, I talk to and mention the validation I've done in my testing, even if it's something that's commercially supported, because I'll give you another secret. Commercial tools are wrong too, all the freaking time, because they take that assumptive data and present it, right? So that's why it's paramount to test, paramount to show things in terms of ways that are understandable. If I have an Android full forensic image, I'll go ahead and run emulation in order just to screen capture the nefarious activity. Another cool thing you can do with emulation is if you have an entirely encrypted app, secret guys, if you own the device and you've gotten into the device and you've got a physical image, you have the keys, and the app knows how to play the keys. So if you actually run emulation, it doesn't matter what encryption's there, unless the data's stored cloud side. In which case, guess what the secret is then? Impersonate the account via tokens, and then you have the data. So you can do all of that in emulation, screenshot it, and then that is very well prepared to present to court for lay people. In terms of validating and showing your results, that is really the importance of explaining your test scenario, what you tested, how you validated each field, and that would go into a deeply technical report that would be an addendum. But thank you, great question. Yes?
What makes you more passionate about
What makes me more passionate about mobile forensics as opposed to other parts of forensics? A couple things. One, I started off in a mobile forensics lab, so that may be where like my deep-seated passion is. But two, because it's always changing, and I love a challenge. I love puzzles. And three, it's not just that it's changing, it's harder. And it's harder because it's not just the operating system you have to deal with. There's differences between the hardware, the operating system, the application. Each one is a different complexity. There's less standardization across the environment, which means there's more room to play. Plus, I come from kind of a hardware hacker kind of background, and then it means I still get to solder. And if I was just doing drive forensics, I wouldn't get to still, JTAG, ISP, all that kinds of stuff. And if you really want to know where I spend a lot of time now, too, I'm playing a lot with IoT forensics, and it's the same place. And to be honest, I also like to kind of play on the verge of where there's a lot of questions. And some of the other issues with mobile forensics is when you do a computer forensics image and you're doing something that's dead, right? You make a computer forensics image, you use a write blocker, there is no question about the fact you haven't altered data. When you do a mobile forensics image, how were we just doing a mobile forensics image? We were doing it live, right? We were communicating directly to the device. I am actually making a footprint. I'm changing things. It's the same reason I like memory forensics, because I have to be so much more on my game about my methodologies and what I'm doing, and there's so much more complexities. And there's so many more version changes regularly. Yeah, it's just fun. And to be honest, how many of you have a computer in your pocket? No, but you all have a mobile phone. Yeah, this is the wrong room to ask. That was about 25% of you. I should know better. I mean, how many? Right. But let's say that, right? How many of you are rocking more than 2 phones? Or how many of you are rocking more than 1 phone? Right, most of you. How many are you rocking more than 2? I got 3 on me right now. I will confess 1 is a test device. I'm data populating while I'm here for a CTF I'm building, but that's just fun. But great question. Any other questions? Yes?
How common is it to see evidence, conversations in actual criminal cases using unusual applications that are not ones that top 400 or whatever?
So the question was, how common is it to see applications that aren't the top 400 that are supported or so in actual criminal investigations? So as somebody who's done lots of investigations, I will assure you that as somebody who looks for it, I found it lots of times, but if you only poll people who just rely on their tool outputs, they will tell you it never happens. So it never happens if you don't know to look for it. But if you know to look for it, you will find evidence regularly. So guess what bad guys do? Nefarious actors know what tools support. And there are actually sometimes shared TTPs saying, hey guys, don't use this anymore. The cops know how to parse it. And they share that information amongst each other. It's a game of cat and mouse. So if you can parse something, not tell them you know how to parse it, and then read the content, that helps. They'll find out when you get to court. So the entire organization will know then, and then they'll move on to something else. But yeah, it is a game of cat and mouse. It's a fun game. And I'll give you the other tidbit. So when I do mobile forensics, I'm typically doing mobile forensics on a dead mobile phone. Most of your applications that tout end-to-end encryption, secret, that end-to-end encryption means once it's off the device, if I have your device, I have everything, especially if I can emulate. And lots of things that even store encrypted can be broken quite easily, because the keys are on the device too, as is the application that knows how to run the keys. Like, it's all right there. So it becomes less of a challenge. Now, if you're limited to backups because of scope or time or capabilities, you're limited to what you receive, because a backup of a phone is just going to be the parts of the information that the developer chose to back up. Now, there are cool ways around that. So, for example, WhatsApp stopped backing up user data. But you know what you can do? You can temporarily push the old version of the APK onto the device, ask that version to push back the data. That's called an APK downgrade. Get the data from that, and then swap back the APKs. It's cool. Hope you don't brick it is true. And again, I will stress testing is important. And please validate and verify anything you're going to do on another device. And I will give the big caveat. In forensics, it depends, and there will be things you won't get into. So let me give that, caveat. It depends, and there will be things you can't get into. But oftentimes, everything's on the device. You just got to think outside of the box, think like a user, figure out how the data had to be made available to the user, and a lot of times that'll be your win. Like the day that Apple changes their iTunes backup, right? And I'm like, oh my gosh, none of my tools will support it. I can't even get an image. Apple still needed to make the iTunes backup work, so I can still just get a backup. By the way, if you use an iTunes backup in a case to try to pull your data, please, 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 for the love of all things forensic, disable or enable the button that says prevent iPods, iPads, and iPhones from syncing. Otherwise, you will be sharing your data with your nefarious actor. And then you're going to wonder why your mom's in the bad guys contact list. Any other questions? Yes?
Do you use these techniques a lot on the defense side? So if I pull an officer, just phone playing WhatsApp on a Friday night, do you do a little free?
So I have never worked on the defense side. So I have lots of friends who do. But the forensic methodology doesn't change. Forensics is forensics, and everybody should understand the right skills. Now, I can use stuff like battery usage monitor and recent tasks to determine what activity has or hasn't been done. And I'll actually tell you a quick story about how I wound up with that research that was at the beginning of that, where I was able to show the file system actions of the phone. And that actually came out of a case I was helping a local law enforcement agency with. And the driver had hit and killed a 5-month-old baby. Horrible case. And there were witnesses who said the driver was texting while driving. And the police department asked for my assistance and some research on it because they could find no evidence either via call data records or on the phone that the person had been texting or using any other chat application. And I was like, wow, this is really hard, because usually I prove something occurred, not something didn't occur, right? And so I was like, I have to figure out how to prove the timeline of exactly what was brought into foreground and background on this device. And that's what the research I did to do that, because to be honest, traditionally, computer forensics, back to your question, has always dealt with looking at the file system and doing file system parsing, whereas mobile forensics, because we started with AT commands, who knows what an AT command is? Yes, this is the right room. Yes, okay, sorry, that was way too excited, but I love it when people actually know what AT commands are. So because we were using modem protocols and we used to just request, give me your calls, give me your SMS messages, we knew what everything we were getting back was. So we had this real artifact-first approach to mobile forensics. And historically, nobody's really looked at it from the file system side, so we didn't have good methodologies to prove what actions were happening in what order on the device. And so when we were able to demonstrate that you could actually determine exactly what app is coming into the foreground, into the background, and that entire life cycle of what's happening on the device, it was a game changer. And we were able to say, it is unlikely that this person was texting while driving, because none of that came into the foreground at the time of the incident. The battery monitor came into the foreground at the time of the incident, but I can't say that that wasn't from the impact, that he wasn't charging his phone and it didn't come loose. I don't know. But it's interesting because it was actually law enforcement asking, but it was a defense scenario of exonerating somebody that was used. So thank you. Good question.
I'm curious, because you hopefully never find yourself in legal trouble, but if you do, how do you
Yeah, so I can tell you another scenario where we've used a Fitbit to prove someone's innocence and exonerate them in a murder case because they were sleeping with their Fitbit on, and luckily for them, they got up to use the bathroom. And the steps that they took to use the bathroom was enough to prove that they weren't at the murder scene. And there was a lot of good police work that was done by that police department because they actually measured his step stride to make sure that the stride count was accurate, et cetera. And they validated the steps, the time of the steps, they validated the cloud data on the server side, et cetera. So there's a lot of really good forensics things where your devices can be your alibi. And there have been many instances where a device has been an alibi, but unfortunately there's been more device instances where nefarious actors are caught doing their nefarious activity because of the device. But at the end of the day, your device doesn't lie, and your device is going to tell the truth, providing that you understand what the data means, and you're only going to get that from testing. Any other questions? Yes? Oh, heck yes. You mean in, huh? Oh, I'm sorry. So the question was, is there ever collaboration between forensics and developers? And my answer was, heck yes. And I guess it should go to it depends. So sometimes forensics doesn't communicate with developers because, in all honesty, we take advantage of a lot of exploits. And if we were to close those holes, it would make our jobs harder. And I'm sorry to say that to a room full of security people, but it's the truth. Sometimes security and forensics are at odds. I need open holes. Sometimes we do vulnerability. I've exposed vulnerabilities in forensics that I've released back to vendors for them to fix. I've also reached out to organizations to ask questions. Most of the time they don't help. Sometimes they do. It actually depends on the organization's posture and acceptance of privacy and law enforcement in the scenario. And there are lots of times which everybody knows about in which application to security defense have not helped. I would point you to the San Bernardino shooting and FBI versus Apple. That said, what you guys may not be aware of is that prior to iOS 7 and below, Apple actually used to assist on warrants and unlocking devices for law enforcement. They had an entire division dedicated to it. So sometimes times change and organizations change their posture. So yes, no, it depends. There are things they have to comply with legally, but like, do I call up a more open source projects? There are a lot of developers in the forensic space who develop tools open source. Everybody from Eric Zimmerman, and there's a lot of sharing in the community, to Mary DeGrazia, to Harlan Carvey. There's tons of open source development for looking at forensic images, parsing data, getting content, getting into devices. There's entire open source forensic suites like Autopsy by Basis Technology. There's a lot of open source development of forensics tools. There's a very large open source forensics community. In terms of cooperating with the developers of applications to try to understand why or how they may have stored data, there's probably more reverse engineering that happens than that. Because honestly, we'll read a lot of security pubs, and sometimes they're not exactly complete, factual, what have you. You have to test everything and validate everything, because as the gentleman asked before, you do have to bring it to court often, right? So forensic, by definition, means that the data may go to court no matter what kind of avenue you're in or if it does or doesn't, right? You have to treat it as if it might. Because that could be anything from an incident response to a malware incident, somebody leaving a company and stealing corporate secrets, putting things on a USB drive, or somebody committing a murder. One time for one last question. Oh, I have 2 minutes, so one last question. Any other questions? That was your last call. All right, thank you so much. Really appreciate your time.